various types of equipment that control the intake air volume and the output of the engine, the ISC valve of the idle speed control system, the actuator of the cruise control system, the sub-throttle valve and actuator of the traction control system, the controls that were performed by these, and the control of the throttle valve that is required by the vehicle stability control and the electronically controlled transmission. All of these are consolidated and controlled as an integral system in order to ensure drivability and comfort under every possible driving condition by the Electronic Control System Intelligence, or ETCSI. Using the Lexus GS 300 as an example, this video explains ETCSI by describing an outline of the system, the operation of the system, and its fail-safe functions. We'll start by describing an outline of ETCSI. ETCSI consists of an accelerator pedal position sensor, a throttle position sensor, a magnetic clutch, a throttle control motor, and the ECU. The accelerator pedal position sensor detects the depressed amount of the accelerator pedal. The throttle position sensor detects the opening of the throttle valve. The throttle actuator opens and closes the throttle valve. This throttle actuator uses a lightweight and energy-efficient DC motor. The magnetic clutch engages and disengages the transmission of the motive force from the throttle actuator to the throttle valve. The ECU controls the operation of the throttle actuator and the magnetic clutch. This control is effected based on information received from the sensors and the ABS and TRC and VSC ECU. A conventional throttle valve is connected to the accelerator pedal through mechanical means, such as an accelerator cable, which opened the throttle valve when the driver stepped on the accelerator pedal. However, with ETCSI, the throttle valve is not ordinarily connected to the accelerator pedal through a cable. With ETCSI, based on the movement of the accelerator pedal and the information on the driving conditions, the ECU calculates the optimal throttle opening and sends a signal to the throttle control motor. As a result, the throttle valve opening is controlled. The throttle position sensor sends the information on the throttle valve opening to the ECU. Now, the operation of the system will be explained in detail. In accordance with the driving conditions, ETCSI effects the following 5 types of controls. the nonlinear control, idle speed control, cruise control, TRC throttle control, and VSC cooperation control. Now let's observe the function of each control. We'll start with the nonlinear control. In order to regulate the speed of the vehicle, if the amount at which the accelerator pedal is depressed is changed suddenly, the longitudinal acceleration speed of the vehicle increases instantly. In such a case, instead of directly linking the accelerator movement to the throttle valve opening, ETCSI gradually varies the throttle valve opening in stages, thus restraining the engine torque from fluctuating suddenly and preventing extreme changes in the longitudinal G of the vehicle. As a result, excellent riding comfort is ensured. If the driver turns the snow switch on, the amount of change of the throttle valve opening is reduced to restrain the sudden fluctuation of engine torque. As a result, on slippery terrain, the driver's ease of throttle work has been improved. In the past, the volume of intake air at idle was controlled by the ISC valve, which varied the opening of the bypass passage. With ETCSI, this function is carried out by the throttle valve. With the cruise control system, the cruise control actuator pulled on the throttle cable to open the throttle valve. With the ETCSI, the throttle actuator opens the throttle valve. With the TRC system, the subthrottle valve, located before the throttle valve, restricted the intake air volume according to the need in order to reduce the output of the engine. With ETCSI, the throttle valve closes in order to effect the required engine output control. Furthermore, ETCSI effects VSC cooperation control. Under VSC cooperative control, if it is necessary to restrict the engine output in order to control the vehicle's posture while driving on slippery terrain or cornering, ETCSI closes the throttle valve. Through these four types of controls, ETCSI improves the vehicle's drivability and comfort in order to ensure the level of vehicle stability that is appropriate for the high-performance vehicle. Now we will describe the fail-safe function of ETCSI. Both the throttle position sensor and the accelerator pedal position sensor of ETCSI has adopted a dual construction consisting of a control sensor and a malfunction detection sensor. These two sensors consist of a control sensor that has a linear property throughout its range and a malfunction detection sensor that has an offset voltage. The ECU determines a malfunction by comparing the difference in voltage between these two sensors. Furthermore, a malfunction of the throttle control motor or of the magnetic clutch is determined by comparing the command signal that is output by the ECU and the signal that has been detected by the throttle position sensor. If a malfunction occurs in the system, the ECU illuminates the check engine lamp to alert the driver of the malfunction. At the same time, the ECU stops the system by cutting off the current to the throttle actuator, disengaging the magnetic clutch, and turning off the power to the electronic throttle drive system. As a result, the system effects its operation in the limp mode. Although the throttle remains closed in this state, by pressing the accelerator pedal further than a certain amount, the throttle valve opens via the limp mode lever. Consequently, the vehicle can be driven in the limp mode even if a malfunction occurs in the system. If a malfunction occurs with ETCSI, the check engine lamp shows code 89. At this time, DTC, a diagnostic trouble code, is shown by the snow indicator light or by the ETCS indicator light in the case of the GCC specification model. This completes our description of ETCSI, which has been newly developed for the purpose of improving the vehicle's drivability, comfort, and stability. We hope it was informative for you. Please refer to the new car features and repair manual in order to understand this system in further detail.